Greetings, I am Vanessa Rolim, and today I will present the paper submitted by the research group I'm a part of in Instituto Federal Catarinense. Our goal here is to show and discuss our method for identifying partners of movement of trajectory sets by using the frequency distribution of points. In order to achieve such goal, I will start this presentation by unveiling our motivation. Then the proposed method will be shown. Next, the experiment will be described and the results will be analyzed. Finally, our conclusions will be discussed. Let's start with our motivation. We must find movement partners among a group of trajectories. To this end, we usually make clusters of similar trajectories. This process may be done through different parameters, such as the distance between 2 points of 2 or more trajectories, the distance between the trajectories themselves, or through trajectory segments. This clusterization may describe the movement into a neighborhood. There are a number of different methods for that end, and this work is proposed to do another one. For the experiments, our method was compared to TRAJREF, which is a framework for partition and group. This algorithm also has an input of a set of trajectories. Those trajectories are partitioned in a set of line segments. Those line segments are then grouped by distance amongst each other. Inside each group, a trajectory is defined where there is a greater concentration of points. In order to compare the methods, 3 experiments were conducted, using a database with 7 trajectories, simulated on the city of Joinville, a city in South Brazil. They were collected using the app My Maps, which is an extension of Google Maps. For the experiments, we used the same radius for the areas, but the algorithm have different scale. Therefore, epsilon is the parameter used in TRAJREF, and d is the parameter for TRAJREF. The first result is for the experiment with the radius set at 15. On the left is TRAJREF's result, with 2 trajectory segments. The proposed method on the left shows a reference trajectory, which has more points than TRAJREF's. The second experiment, with the radius set at 20, shows a similar result, except that TRAJREF has 3 clusters, shown by the different color segments. TRAJREF, however, has a greater accuracy, showing a single reference trajectory that matches the shape of the input set. The final experiment again shows a similar result. TRAJREF does find a cluster on the far right of the set, but does not find it on the upper left. On the other hand, the proposed method finds the cluster on both sides. The results show that TRAJREF finds a greater amount of cluster than TRAJREF, as seen on the green highlight. On the downside, it only returns 1 reference trajectory, where TRAJREF finds several segments. These are the images of a frequent area zoomed in. When that is done, it's possible to see that when the radius increases, the amount of neighbors also increases, as expected. Finally, an experiment was conducted using 2 identical trajectories. TRAJREF could not find many clusters, which is unexpected once we consider that the trajectories are identical, which implies that the points on those trajectories are also identical. TRAJREF, however, was able to find the cluster through the whole trajectory. The only major difference between these experiments on TRAJREF are the amount of points on the representative trajectory, which are the clusters found. This shows that when the radius increases, the amount of cluster decreases, as we expected. As a conclusion, we found that the proposed method was able to find clusters of trajectories considering the frequency of points based in an area defined by a given radius. The method was also successful on returning a reference trajectory based on the set of clusters. TRAJREF presents similar results to those found in TRAJDATA, even though it does not have a segmentation step, which seems to increase the fidelity to the shape of the original trajectories. TRAJREF, however, is not able to identify different clusters along a reference trajectory, like TRAJDATA does. We plan, as future works, to enable the algorithm to generate several reference trajectories in order to represent different sets of clusters, as well as develop an additional step to prevent points of the same trajectory to be considered neighbors of a candidate point. We thank you for your time and attention. If you have any doubt, please do contact us through any of these emails. Thank you.